Thank you for joining my session. My name is Michał Brygidyn. I work for Xebia from Poland. And today I want to show you my research. I'm a security researcher. I'm a AWS ambassador as well. And I try to find different ways to get to your AWS accounts, to get admin access on your AWS accounts using many different small misconfigurations. And today I will show you how I do it so you can secure your accounts so nobody else will do it. This is a very similar presentation to one that I had last time on ContainerDays, but I added something at the end of it. It's for AWS backdoors, a presentation that I will have for this year. So let's start. There are still some seats available here in front if you want to come here. First scenario is very, very simple, HTML. And this is funny, but you can find many different sensitive information just in HTML code. What to do? Just view the source code, and you can find, for example, some comments left by developers for another team who is running the app. And in the comment, you can see configuration for AWS access. It's a profile configuration with AWS access key and secret access key. So all you need to communicate with AWS account. And this was very, very simple scenario because it was admin access already. This user had administrator access policy attached to it, and it was left in the code and deployed. What went wrong? Very simple explanation. Sensitive data left in the code for next team to let them know how it works. So we don't know what documentation is, so yeah, let's leave it in the code. They will see it, then they should delete it. Yeah, why not? And that's the first one. Very, very simple, as I said. Next one is more complex, and it starts on GitHub. If you use GitHub, you know that you can have either public or private repositories. And while private, I shouldn't have access to. So for public repositories, anyone can access them and can check what's inside. And in my scenario, I was looking for Office 365 credentials. And I found a file, a config file in one of the projects. And while there are many config files that are plain text, and you can easily just grab login password, key, whatever from the file, this one was more interesting because values in the config file were encrypted. So something more interesting than others. And I started digging in that repository, in that project, and I found a Java class with decrypt function and a secret key hard-coded in that decrypt function. After I reported that, I asked them why, and the team told me that, hey, it's the only place where we use that, so why not? These are some examples from public GitHub repositories. You can find database credentials with some endpoints, public endpoints with no firewalls on them. You can find login password to different payment providers, payment gateways, or to different clouds. Recently, I found Jupyter notebook files with a piece of Python code, for example, definition and a configuration of IBM Cloud credentials, something like that. And then in Jupyter notebook files, you have a piece of Python code and then the output. So I got both credentials and the output from their database. And then another part where is another part of Python and still more data because they process the data and yeah, it's perfect. It's all in public repositories. But let's get back to our scenario. We have this config file and decrypted Office 365 credentials, valid credentials. So what are the options now? First of all, this user had his subscription for Teams, for example, Microsoft Teams. So first idea, let's send a message to CTO, CEO, whoever. Hi, I'm a security researcher, and you have an incident here. But this will not give me admin access to their AWS account. So instead of that, I checked SharePoint. If you create Teams groups, you can either set these Teams groups to be public. By public, it means available for everyone in the organization, or private, just for people that you invite. But many people just do it public for all in the organization, and it means that if you get access to any account, you can access anything inside these groups. And one group was created by help desk team, and there was a PDF file with Jira configuration. They were asked to set up Jira, to configure it, and to make sure that it's running, it's available. So they did that, and they documented every single step, including creating an admin account with login and password, and all that in PDF file on SharePoint, available for everyone in the organization. So I used that to log into that Jira, because this Jira was public. Anyone was able to just open it. And I was looking for AWS, so simple search, AWS, give me all projects with AWS in name. There was one project with a task, someone needed IAM user with credentials for some external tool, CI/CD tool, and this user had to be admin, so they just added a comment, here are access and secret keys for that user, just use them. So that's what I did, admin access, done. What went on here? First of all, hard-coded sensitive data. There are many better places to keep your passwords and keys than the code itself or the repository. There are some secrets managers, vaults to use, and also Git remembers everything. Git has a history, so if you push something to Git, make sure not only to override it, so the latest version is clean, but to also rotate the password to change it. So if I get access to your repository and I will browse the history, whatever I find is not valid anymore. That's very, very important. Next thing, bad tool selection. As I said, a public repository. It was help desk app. They are not developers. They didn't know what to use, so they just took the first thing from Google, and they used that. That's why it was public. And they didn't know how to share credentials with whoever may be interested in that, so they just put it in PDF. And lack of security awareness. Many cases where people are using their own personal or business accounts, like in your company domain accounts, to automate something, and they put their own credentials there. There are service accounts available for this purpose, so you don't need to do that, and you can configure service accounts not to have access to any other services. But when you use your own account, whoever gets access to your account will get access to all places where you can go. Next one is Symfony Profiler. Symfony is a PHP framework, and Profiler is a development tool that helps developers to debug the app. And Profiler has nice features, like it can show you server parameters, it can show you all requests in plain text, including post requests to login endpoint with plain text login and password. And in older versions, you were also able to preview any file from the directory of Symfony. And there was one very interesting file, parameters YAML, with passwords, keys, etc. So that's our starting point. Very easy to find all public profilers using different search engines like Census, Binary Edge, Shodan. But when we find one, here's the example of environment variables. You can already see AWS credentials here, but these are credentials just to access S3, full access to S3, but still only S3. And there we also have an example of post request to login endpoint with login and password. So just grabbing this login and password, you can get to that app. And this was development environment. But what I am always doing, if there is a development environment, there is a production one. If the password looks complex, maybe it will work on the production environment as well. So let's get rid of dev.example.com and just log into example.com. Guess what? It worked. And this app was some internal app with single sign-on available to different internal apps, including CRM or webmail. And CRM, only some more or less interesting data for me. But in webmail, I was looking for AWS. So when I checked the webmail, there were many emails from AWS, like Trusted Advisor, like invoices. So first idea, hey, maybe it's a root user email for AWS. Why not try that and reset the password for that user, for that email? And I tried that. I reset the password. There was no MFA. I was able to log in, and it was not just the simple root user for a single AWS account. It was a root user for the organization management account. So instead of admin access on a single account, I got admin access to like 20 or 30 accounts. What went wrong here? First of all, production data on a non-production environment. It was not only the same password for admin, it was the same database with all other data as well. And they told me afterwards that they had a bug on production that was not on non-production, so they just dumped the production database to restore it on non-prod to debug it, and they forgot to clean it. And then there was also issue that they were using the same email of this super admin user to register for more than one service. It was AWS, it was Office 365 administrator, it was Datadog, Cloud Health, or some others as well. So getting access to a single inbox, I was able to get into all their tools. Easy for me, easy for them. And they also were reusing, they were sharing their passwords to these shared accounts with many people, so there was no MFA, because, hey, the whole team is using that, and we cannot have MFA on that, because who will approve that? And if you don't have MFA and you share the account, nobody feels responsible for that account. Nobody feels responsible to change the password, to secure the account. And that's why it was so easy to get there. Next one, Kubernetes. Who knows Kubernetes? Sorry, I had to do that. Kubernetes. I noticed like 2 years ago that every week there are like 100 or 200 new IPs with Kubernetes API with no security on it, no role-based access control, nothing there, and like 100 every week. And I have a tool that scans Shodan, Census, Binary Edge, and Zoomai. To give me all IPs with open Kubernetes, and then another tool based on Lambdas runs different queries to extract secrets, basics for secrets, config maps, list of pods, configurations of pods, to look for juicy information. This is the example. I didn't hack anything. It's public. With just a web browser, you can ask for API, for pods, for secrets, for config maps, and this is what you get. Of course, for secrets, it's already basically for decoded, but still, it's that easy. Nothing special, just web browser, and you can get credentials. But if you want to access more than just text data, then you can use kubectl and configure a dummy endpoint, dummy API endpoint with dummy user and password and that IP, and it will let you in. So I checked all these config maps and secrets. I found access keys for S3. Not enough, just S3. And I also found admin credentials for Jenkins. And now we have two ways to access that Jenkins. We can either find public Jenkins endpoint, or we can forward ports to our local machine to access Jenkins running on one of the pods from our local machine. Both ways available here because the Jenkins was also public. And when I access Jenkins, on Jenkins, if you know how to use it, you can extract every single credential stored in Jenkins, because with access to Jenkins console, you can decode everything from credentials. There were GitHub login passwords. There were some access keys for different parts of AWS, like Lambda only or SQS only. Still not enough. But in build logs, I noticed that there are some AWS CLI calls. So there was another configuration somewhere. And I decided to use kubectl exec to get into that Jenkins pod. And there was IAM role attached directly to it. So when checking what I can do from CLI from Jenkins pod, I was admin there. So yeah. Easy. What went wrong? First of all, public resources. Why someone would want to deploy their unprotected Kubernetes API to a public subnet? No idea. I'm not a Kubernetes expert. I just know how to hack it. And sometimes the problem lies in the limited scope of penetration tests because companies don't have the full asset list. They think that that's all, and they ask their testers to just focus on this asset list. But sometimes there are other assets as well, and instead of just doing pen testing on the assets list, you can ask someone to do pen testing based on keyword. And starting from a keyword, you can check these most evil search engines, as I mentioned, Shodan sends this binary edge to give you all information about endpoints, IPs, that contain your domain name, your project name, your other top secret name. And then you will find your resources that are publicly available. Also, if there are default security features, please do not disable them just to make your life easier, because it also makes my life easier, because then I don't need to break anything to get your data. And yeah, principle of least privilege. So if you have to remember two things from my presentation. First one, use MFA everywhere. It makes it a bit harder to get into your stuff. And the second thing, principle of least privilege. So give your developers or yourself only the level of access that you really need to do what you are going to do. Don't give admin to everyone just because they asked for it. And there are also other ways to access your, for example, production environment, even if you don't have access to it. For example, if you have a full delivery pipeline, CI/CD pipeline, and it is automatically triggered from a change in repository, and you can push directly to that repository, you have access to your prod, because you can push whatever you want, a piece of rogue Terraform code or a backdoor in the application. It will be automatically deployed. If you don't have access to your repository, but you can add or modify jobs on your automation server, you have access to production, because you can add another job that will deploy something for you on production. And there are more scenarios here. Slides are still not ready. And some of them are, for example, outdated software running on cloud servers. As an example here, Jira in version up to 7.3 had a bug in OAuth plugin that it worked as open proxy. So if you have access to Jira, you have access to this proxy. You can just ask it to give you metadata endpoint details from the cloud, asking for temporary access and secret key that this EC2 is using right now. And that one was using pretty high permissions there. Then we have admin credentials logged during installation. I was asked to audit one of one of my clients' environment, and I noticed that they have CloudWatch logs with full log of installation of Jenkins, and last line, login and password. So with just read-only or security audit role, I was able to go up to admin on their account as well. Misconfigured virtual hosts with the directory indexing. You can have your virtual host for your domain defined in a way that it will point to one of these folders. But then there's a default one that you don't know for HTTPS, for example. It will be one level higher, and it will give you access to project files, and then just check .env file, and there are some interesting things inside. Debug pages, connection strings, Python Django. If you use Python, there are pages like this, and most of interesting things are hidden, but there's a broker URL that consists of access and secret key in the connection string that usually not only giving access to SQS, but more services as well. And now something new, AWS backdoors. This is my topic for this year for a bigger presentation, but it's a small teaser. Previously, I showed you how to get admin access on someone's account, and now I will show you how to stay there for a bit longer. Not to let you stay there for a bit longer, but to let you prepare for someone trying to do that. First group, EC2s. EC2s can be public, so if it can be public, someone can access it from the internet. And if you have admin access or at least EC2 access on someone's account, just create EC2, attach the IAM role to it, and you are able to access it from the internet to do whatever you want, because it will have a role on it. Or you can create a local user. You can, for example, start a session on a running EC2, create a local user. Nobody will know that something changed because this EC2 was there like forever. And you just add your own user on that EC2, and it's public, so you can just log in. Second group, IAM user. These are groups of how you get into AWS, and this is one of the ways. Just create a new IAM user, name it with the same convention as other users to make it harder to find. Or if you don't want to create a new user, create a second access secret key pair for any existing user. And this is also something to check for your current users if they have more than one key, because I don't know any scenario where I would need 2 keys for my user. So if there are 2 keys, maybe one is mine. Second group, or third group, IAM role. You can use IAM roles to let someone in from another AWS account. So if you have roles on your account, you can configure trust relation, or I can configure trust relation for you, trusting my external account. And thanks to that, I can use my external account or someone else's account to assume your role on your account with your permissions there. And that's one way. If you have access to EC2 with a role that's not admin, but you have permissions to modify policy versions, modify a policy version for that EC2, then hey, you're admin and you have access to that EC2. Or you can just replace the role that was used by EC2 by any other role with admin policy attached to it. And the last group, network access. It will not give you admin on AWS, but it can give you access to internal network. For example, the easiest one, just change or remove any rule on security groups, and if there is no infrastructure as code for it, nobody will notice that, and you will have access, or everyone will have access to someone's network. You can try to do VPC peering with your VPC on another account, or you can try to set up transit gateway attachment to your account, your or another hacked account, to also get access to someone's network. And these are ideas how to stay there for a bit longer. And now ideas for the survival of that solution, because hey, someone just found my backdoor and removed that. But I have a Lambda with either cron set up in CloudWatch or API gateway or a direct link that's available right now. And I can just open that link and the Lambda will recreate everything for me. So you need to not only find my backdoor, but also my Lambda that is recreating that. I can set up step functions to recreate that after a specific event, after 2 weeks, for example, not to make it immediately, but after 2 weeks. Or I can have code build also with some cron that will run weekly, daily, weekly, monthly. That will still recreate everything from Terraform from somewhere. And if I don't want to be detected, I will not use administrator access policy, because many tools, many professional tools mark every single user and role with administrator access policy attached. So instead of that, I'm using power user and IAM full. It's the same as admin user, but it's not marking my role as dangerous. And also, you can try to run all your tools from the same place where you found your credentials. For example, if you have access to EC2 and you extracted EC2 credentials, do not use them on your local machine because guard duty will find it, because other external tools will find it. Just run your tools on that EC2 and you will get the same outcome, but you will not get detected that easy. Thank you. Do you have any questions?
Did you have a use case for your backdoors?
Did anyone heard that?
I will have on my full presentation.
Okay.
I will be here the whole day, so if you want to ask, just catch me.